Hello, welcome to Mastering DevSecOps in CI/CD. My name is Jim Hirschauer, and I'm joined today by Prashant, who is one of the co-founders of Devtron. So today we're going to talk about DevSecOps. We'll do a little bit of presentation work up front, and then we'll get into demo. And we do have live Q&A that we'll be doing. So as you think of questions, feel free to type them in and we'll get to those towards the end. We're also going to have a free content offer at the end with content that is complementary to the information provided in this conversation. So with that, we'll get started. I'm going to introduce Devtron just a little bit to you. So we are a software delivery acceleration platform for Kubernetes applications. And what we'd like to do is talk about adopting Kubernetes as a journey, because most companies don't start in Kubernetes. Most companies start with something else. And even if you are starting off with Kubernetes and natively there, you're still going to hit most of these phases as you go through. And many companies, they've built their software delivery processes over many years in their non-Kubernetes environments. And then when they try and move to Kubernetes, they do struggle with getting many of the capabilities put in place that are required in order to appropriately meet the needs of the business. And so this Kubernetes journey is from left to right. On the left side, you could see adoption, where companies are getting their clusters set up and getting an app up and running. And then moving to onboarding, that's where after you've got that one cluster set up, we've got we want to try and move as many other applications and microservices onto Kubernetes as quickly as possible with all those proper processes and security considerations in place. Moving on to accelerated delivery, this is where companies are really trying to get all their processes, and DevSecOps really fits into this area. All of the shift left processes throughout software delivery lifecycle built in with their Kubernetes infrastructure and getting apps onto Kubernetes. And then on the far right, we've got enhancing stability, where companies are really looking at things like advanced deployment patterns like canary deployments, blue-green deployments, making sure their resources have enough, making sure that their nodes have enough resources so that these applications are stable. Now, as companies build this out, typically there are still many steps here that are not automated. And so any of those steps that aren't automated, we consider toil. Those are things that could be automated, but you still have lots of manual process intervention that needs to occur. So for companies that are anywhere on this spectrum, even if you've been doing Kubernetes for a while, typically what we see is there's still a lot of toil involved in those processes. So getting here can take months to years. With Devtron, we accelerate this process into either days or weeks. So we're able to really obfuscate the complexity of Kubernetes, really kind of hide that away, and minimize the amount of toil that occurs across all of these different stages of this Kubernetes journey. So let's move on to the next slide. Why does this happen? Well, there's a few different reasons. First of all, there's not loads of Kubernetes experts to go around. So in many companies, there are a few Kubernetes experts, and then everyone else has sort of a fundamental lack of knowledge in the space. In addition to that, most companies are trying to use their existing technologies to work with Kubernetes. These are technologies that are not cloud native, not Kubernetes native technologies that require lots of extra steps to make them work with Kubernetes. As a result, what ends up happening on the right here is you get a bunch of different tools put in place. You get lots of scripting done. You get tool sprawl, which this all causes a lot of extra maintenance overhead. So let's talk about Devtron really quickly. What is it? On the bottom of the screen in gray, these are the foundational design principles. So when Prashant is thinking about what should be added to the product, these are the things he thinks about. And then the product itself is on top. And so you can see two core modules, the CI and the CD for build and deployment. And then across those modules, we've got all of these other capabilities: DevSecOps, guardrails, governance, insights, and efficiency. So we're really going to focus in mostly in the DevSecOps area and some of the guardrails area today. And so This is going to be the core of what we talk about, but we'll definitely dive into a little bit of all of these other areas since DevSecOps really does cut across everything. Now, I did a little bit of research before this presentation and found some really interesting metrics that I think are important. So I've got three numbers on the screen: 90%, 206, and 70%. Of course, I'm not going to ask you to guess what these mean. But what they are is, first of all, 90%. That is from a 2017 study by SafeCode, where they found that 90% of software vulnerabilities are actually coming from third-party components, which is really interesting. Software is made up of so many different third-party components today. The number in the middle, 206, that's from a 2023 study by IBM. And that 206 is the number of days. So that's the mean time to detect that a breach has actually occurred. 206 days. That's tremendously long. That's what, 2/3 of a year approximately. That is far too long. By the way, I don't have the number up here, but I did find a metric that said each one of those breaches costs the company approximately $4 to $4.5 million. So imagine that, 206 days of being vulnerable before there's that gets detected. And then adding on to that, on the right-hand side, that 70% number, that's from a 2024 Verizon study that said 70% of breaches actually involve known vulnerabilities. So to me, what that means is that 70%, those are avoidable. If they're known vulnerabilities, we should be able to avoid those, and we should know about those ahead of time and not put those into production so that they can get taken advantage of. All right. So we talked about, in the title, there's a strategic approach, right? And so in the title of this conversation. And so this ideal approach that most companies follow are these 6 steps. So step 1, define your security objectives. Step 2, do some basic threat modeling. Step 3, make sure you hire the relevant people. And then you can move on to doing these 3 things at the bottom. And these 3 things at the bottom are what we're really going to focus in on. So number 4 is observability of vulnerabilities. Do you know what they all are? Can you detect those vulnerabilities before they make it to production? Step 5, make sure there's guardrails in place so that compliance, the entire software delivery team has to comply with those guardrails, so you can't skip steps along the way and have vulnerabilities squeak out into production. And then number 6 is implementing governance, strong governance like security, role-based access controls. There's a whole bunch of things around governance that should be done. So what are these challenges that prevent companies from implementing shift-left security or DevSecOps in a meaningful way? First of all, collaboration. DevOps, the culture of DevOps and DevSecOps is about collaboration. It takes good, strong communication and collaboration in order to make it work effectively. Second thing is that there's a skills gap. So as we're shifting security left, developers are not trained in security best practices. So it's important that somehow they're getting, again, from a collaborative perspective, getting those best practices and those skills from the security team. And then on the far right is tooling. Often there's just inadequate tooling in this process. There are some open source tools that are utilized, or maybe some vendor tools, and the developers are counted upon to know how to use those tools and go into those tools and jump around in their workflow, which slows down them delivering quality software into production. So those are the challenges we're going to focus on. And Devtron offers a solution to these shift left challenges, where it's a platform and the stakeholders can interact with each other. There's mutual understanding of what's going on within the system. Everyone gets to see and work from the same data. The data is deduplicated and normalized for everyone. And then the stakeholders, they get to take action independently without stepping on each other's toes. So, there can be exceptions put into place. There can be, time constraints put into place, but there are different roles within the software for the different involved parties. And then also, what's absolutely critical is to not be an impediment to velocity in software delivery. So that's one of the important things that we'll focus on today as well, is how do we maintain that high velocity in our software delivery lifecycle while introducing DevSecOps and shift left security. So last couple of slides here before Prashant jumps in and starts to show you the things that we're talking about. So with Devtron, I showed that it's built on CI and CD, and you can have Devtron's CI and Devtron's CD in place with DevSecOps. So utilizing all Devtron modules to work together and collaboratively. That's one methodology. But if you're not using Devtron CI/CD today, that would require a rip and replace. The other methodology that's available is overlaying Devtron's DevSecOps capabilities. So you can use your existing CI/CD tools and actually then overlay Devtron from a DevSecOps perspective. And we'll go ahead and we'll do vulnerability scanning and provide a lot of these capabilities that we're going to talk about today right into your existing environment. So with that, I'm going to hand it over to Prashant. Prashant, go ahead, take it away.
Perfect. Thank you, Jim. So Jim gave a very good overview about Devtron as well as about the DevSecOps things, right? So there are two broad areas in which I'm going to talk about. So one, I'm going to talk about shift left versus shift right, right? So that's something that I'm going to talk about. What is shifting right? What is shifting left? Right. The second thing that I'm going to talk about is what a correct setup for DevSecOps should look like, right? Because that's another important thing, because we hear so many things about DevSecOps. What kind of a setup would be the right setup for the DevSecOps? Is it completely towards left? Is it towards right? Or is it something else, right? So that's, and what are the different components that we should have in that? That's something that we're going to talk about, right? Another caveat in this is that we are going to talk primarily about the vulnerabilities in the code and the images, right? Because there are other kind of security breaches which can also happen. For example, you might know about the API security, right? The hardening of the infrastructure. That's something that we are not going to talk about. That's outside the purview of this particular webinar that we are having. We are just going to focus on the images which have been created with your own source code, how you're going to deploy them, and what kind of security posture you can have in that whole process. So that's what we're going to talk about. Right. With that, let me come back to left versus right. Right. So what does right mean? So if I go to the resource browser in Devtron, so resource browser is something which shows you what are the different Kubernetes objects which are deployed in your cluster. And I may pick any workload. It may be job, it may be pod, it may be deployment, replica set, anything, right? So just for a simplicity's sake, I'm just picking up a pod, right? Now you see this vulnerability. Just hold on for a minute. You see this vulnerability over here, right? The list of this vulnerability over here. There may be multiple images connected to it. This is the list of the vulnerability which is present in this image. Now, if you look at it, this is already in the cluster. That means somebody has already deployed it. It's within your cluster. And that is why it's on the right side, right? So basically the time to take action is much later. And as you start shifting towards left, you can take action much faster, right? So what if I had known that it has the vulnerabilities when I was about to deploy it, right? What if I had known that it has vulnerabilities when actually I was building the image itself, right? So the idea is like, how quickly can I know about the vulnerabilities so that I can implement my fixes faster? But then there is a catch to it, right? Why? Because when we look at developers, right, what is their main KRA? Their main KRA is to ship out more features, more capabilities. Now, a lot of these vulnerabilities that are being discovered may be related to the code or the third-party libraries that we are using, as Jim was talking about, where 90% of the libraries that we are using are the third-party softwares, right? The open source libraries that we are using. So they may have vulnerabilities which they have to update, and a lot of times it may have to do with the images, the base images, right? Or some of the libraries which are already pre-installed in the or pre-set up in the images, but are not being used by the particular code. Now, developer may not want to get into that loop right at the get-go. They may be fine with taking up that loop once they know that their code is fine and they have built it to a certain level. but they may not be fine with saying that, okay, this is the first thing that I'm going to do, and I'm going to spend like various cycles or waste various cycles doing it, right? Again, I'm not trying to say that that's the right way or that's the wrong way. I'm just saying that in some of the organizations, this may be the call, right? So where the left is would also depend upon the right optimization that you may want to do, right? So, but that is moving towards the left, where you're saying that how soon can I tell developer that there are vulnerabilities in the system which needs to be fixed, and we have to do it in such a fashion that we don't end up frustrating developers or end up sending them on a wild goose chase where at the end they are not able to actually take any credible action on the vulnerability which have been discovered, right? So that's the left versus right, right? So right is when we are saying that we are getting closer and closer to deployment and even post deployment, and left is when we are going closer and closer to build, or even let's say when the developer is actually writing the code or has started writing the code, right? So that's the left and the right. Now coming to the second portion of it, right, where I said that now I'm going to talk about what is the correct setup for the right DevSecOps positioning, right? So first portion, of course, of any of the security posturing is the access control, right? You should have the right permission levels. Who can override what? Can anyone decide like, oh, I just want to remove, let's say, vulnerability scanning from the build pipeline because it's taking time? Can I take that call? Do I have that ownership, that authority to take that call? Am I mature enough to take that call, right? So the point is saying that, do you have the right access controls where you are, where the people who are responsible for it and who are aware of it are the ones who are taking call, and not anybody can decide what they want to do with the system, right? So that's one. And connected to it is also from the policy angle, right? And as Jim was also mentioning, that collaboration is one of the important aspects of it, right? Now, collaborations comes from multiple things, but some of the important parts of collaboration is one saying that, do you have the right ownership, so that as we were talking about, you're not stepping on each other's toe. You are working within your own boundaries, but you are able to perform best within those boundaries, right? So one is the access control, right? The ownership for the collaboration. The second part is also saying that, how do I communicate my calls or my decisions to the other party? Do I have to rely on a third-party system to do it? So, for example, if there is a vulnerability fix, do I have to do I have to open a Jira and create it as a process that everybody has to look at Jira, and if there are no Jira issues open, only they can deploy? Or can I make it a part of the system where where it gets blocked by itself, and if I have to raise an exception, I can just within the system raise an exception so that things get sorted, right? Or do I have to again like go outside and do the system? Similarly, if the other thing that may happen, as you would realize over time, is there are multiple tools which are coming out with the vulnerability or the DevSecOps related stuffs, and some of them may be great in one area, another may be great in another area, or you may have tried some product, it didn't work out that great. Now you're, for various reasons, there is a mandate to move to a different product. How do you go about doing it, right? So that's again becomes a part of a collaboration, and you may want to have some system which is able to propagate those changes quickly, right? So either it may be a centralized place where if you make changes, it goes to every other place. Of course, you need to be sure that you have tested systems out properly. Or you may say that, oh, I want to create plugins and I want to make them mandatory, right? So for example, if I'm saying that from a security perspective, it's important that every pipeline which is deploying to, let's say, preview environment should have SonarQube implemented, or dependency track implemented, or Codesi implemented. So you can make those calls so that the person who is owning those pipelines is able to get that message, that, okay, these are the new tools which have become mandatory. I need to sort of apply them onto my pipeline. I need to test them out and ensure that these systems, the pipeline that I'm owning is bug free based on the new guidelines which have been provided by the organization, right? So this again becomes part of a collaboration, because you are telling them like what is acceptable, what is not acceptable, and within what timelines, right? So for example, it is saying that if you haven't implemented this plugin, then you can just not trigger it build. That means you cannot deploy stuff. But the other thing may be saying that I'm giving you a grace period where I'm saying that, oh, you have to implement it by 10th of June, and if you don't implement by that time, then you will not be able to take actions on this particular pipeline, right? So this becomes a very strong mechanism for different teams to collaborate together, where now they don't have to rely on an external mechanism to say that, oh, that is a common source of truth that doesn't have a capability of stopping us, but we have made a process where everybody goes and check things out over there, right? So your tool should be powerful enough to allow that collaboration in the system itself, right? So that's one of the important things. And as again Jim mentioned, that this ties up beautifully with the tooling issue also. There are so many new tools which are coming in. They are coming with a very different perspective, with a different take on the system, and you may want to test them out, you may want to try them out, right? So your system should be versatile enough to try things out in a different way. In fact, most of the time what we have seen is that it may not, one system that you're using for scanning may not be even enough, right? So for example, if you see over there is clear and there is privy, and there may be many more, right? Because one of the strengths of, most of the time, the strengths of the of these softwares is the strength of their database, right? So how strong is their database, how quickly they're updating their vulnerabilities. So at most of the time, it's not a harm to sort of check multiple databases or multiple tools, so that you know that you are not missing out on any of the critical vulnerabilities which exist in the system, right? So that is another part of it, where even if you're using tools, you may not want to settle on one tool. You may want to use multiple tools to dedupe the system and figure out like what kind of vulnerabilities exist in the system that we are using today, right? And if anybody has any questions, please feel free to type in the comments in the chat window. We'll take it up during this discussion itself, or after the discussion, based on the kind of questions which have been asked, right? So with that, now let me go to the applications part of it, where we are going to talk more about like how exactly you would want the pipelines to be created, so that they sort of enable the DevSecOps systems, right? Now, from a security perspective, right, we have to be sure that the system that we are using adhere to the best policies or best practices for a DevSecOps pipeline, right? So, for example, one of the things, if you look over here, is an image promotion system, right, where you are saying that I'm going to use the same image which I've tested in a lower environment and move it to the production environment, right? You may be using a different container registry, but the image that you're using is exactly the same. Now, this is very important from your perspective also, from the DevSecOps perspective also, because what you're saying is the image which has been tested at a lower environment for the vulnerability, it's the same image that you're moving up the chain to a larger environment, and it's not an image which has been created completely new. Because when an image is created completely new, you may never be sure that it's the same or not, and the testing cycles, the vulnerability scanning cycles may just go waste, right? So from that perspective, you may want these kind of pipelines to be there, all right? So that is what you would want your system to support. Now, again, when we go inside it, we were talking about different tools which exist, right? And again, these are certain things that you may want to leverage, right? So your system should allow you to switch between different capabilities of the system easily, right? So for example, if you look at the system, it provides you capability of SonarQube, it provides you capability of dependency track, there is a vulnerability scanning system, right? So then there is Cloud NX, and there are multiple such, including Copactic, right? So the idea is to say that, can I use these different systems together so that the image which is coming out of the system, I have more comfort with that, I have more confidence on that in terms of the vulnerabilities, right? Then you may also want to have certain systems which can automatically try to patch the vulnerabilities, right? So for example, Copactic that I'm talking about, you may say that, oh, if there is a vulnerability detected in the lower environment itself, I may want to patch those vulnerabilities if a fix is available, and then deploy it to that environment, test it out, and then keep on moving it to a larger environment. Of course, you should ensure that these vulnerabilities, the fixes of these vulnerabilities, go back into your Docker file also. So Or you may decide that I may do it later on. I'm going to do it automatically using, for example, this tool that exists. There may be other tools also, but for example, this tool that exists, right? So your pipeline should be able to find the vulnerabilities and, if possible, patch those vulnerabilities before it moves to the environment, next environment, right? Now, when you look at it, over here, I have been talking more from the scanning perspective, right? But one of the important aspects of the DevSecOps system is also the policies perspective. What kind of policies are available in your system? Your system, you can use different scanning tools, as I was showing you. You may be using Clear, you may be using Privy, you may be using Twistlock, you may be using Snike. So you may be using any of the tools from the vulnerability perspective. The second question is also to say that what are the policies which I want to have for my system? That means what vulnerabilities I would block and what vulnerabilities I would allow. Now, you may think that it's great to block all the vulnerabilities all of the time, but practically you will find that that's not the best approach to take, because there is a cost attached to fixing every vulnerability which exists in the system. So, for example, you may want to say that, oh, for a low vulnerability, I may want to allow the vulnerabilities to go into the whatever environment where I'm deploying, right? And I may have a different SLA to fix them. Similarly, for the moderate vulnerabilities, but for critical vulnerabilities, I may say that if a fix is available, then just go ahead and block it, right? Why am I doing that? Because if I'm just blocking critical vulnerabilities all the time, then I may not even have a fix for it. So how do I send out my release, or how do I even roll back, right? So that is why it becomes important at times to sort of uh, not at times, in fact, it is important that you block it only if the fix is not available, right? So the question over here is like how versatile your policies are. Can you take a call based on the environments? For example, the environment where my payment application is deployed may have a much more stricter security posturing compared to other environments which are not holding any transactional data, where transaction is not possible. That may be just, for example, a search catalog, right? I may have like a different security posturing in the environment. So anything which gets deployed into the same environment as the, or same namespace as where the payment application is deployed, I may want a much stricter policy control for that particular environment, right? Similarly, from an application perspective, as I was saying, like payment application may have a very, very strict security posturing because this has a transaction data, right? So your system that you are looking at should be able to cater to the kind of needs that you may have over time rather than just patching things up. It may even happen, for example, when you have deployed a particular image, there is a bug in that image, your code has some bug, you want to roll back, and then there is a new vulnerability which has been discovered in the base image or in the image of the in the rollback image that you have to use for that particular application. But there is a critical bug, there is a bug which has a high revenue impact. So what should you do about it, right? So in those kind of scenarios, you may even have something which is called an exception handling, right? So you may say that, oh, this particular CVE, I want to provide exception for this particular application or for this particular environment because I need to make this release, and later on I can remove that exception, right? So just in point of time, I want to say that because this is a critical release, allow it to go forward, and then I go ahead and block it, right? So it's important that the policies that you're using are flexible enough. In Deftron, what we have done is we have said that this policy is important, and that is what Deftron provides as an integral part of the system. And then it says that you can bring any scanning product that you may have a commercial agreement with or that you are more comfortable with, or you can bring even more than one commercial products into it. But the system then talks to them with the same language, figure out what are the different CVEs which are defined in the response which is provided by those tools, and then apply these policies in a uniform way across them. So irrespective of the product or the tool that you're using today, when you switch it, when you start using new tool or you start using multiple tools, all of these policies work by default, and you are not bypassing the policies, because the moment you create a pipeline and that pipeline says that I'm going to deploy to this environment and this application to this environment, the policies that you have defined starts applying automatically. Person doesn't have to say that, oh, this is the API call that I need to make to ensure that I'm calling the right API. So there is no chance of error. You just enable it, and those policies get applied seamlessly, right? So with this, coming back again to the application bit that we were talking about, right? As we were saying, like, it's important from the collaboration perspective between the developer and the DevOps and the SecOps team, right? Or the DevOps team also, because what is happening is there are different people who are looking at platform from a different perspective, right? As a developer, I'm looking at building and deploying the system. As a SecOps team, they may be looking at the vulnerabilities across infrastructure as well as application, and DevOps team may be looking at more of an infrastructure side of the things, right? So for the developers, because we are talking about the build and the deployment system over here, for the developers, it becomes important that how can I give them feedback as early as possible in a way that they can also understand and take impact of, right? So for example, what I opened over here is a deployment window where I am saying that I want to deploy an application to playground-dev environment, right? So this is like a typical deployment pipeline. Now, over here, if you see the applications which have vulnerabilities, the images which have vulnerabilities, which are blocked, which have the policy blocked, I'm not able to deploy those images because it's not even allowing me to select to deploy it, right? An existing image may have that vulnerability, right? Because I may have given a CVE exception, then deployed it, and then removed that exception, right? But I cannot deploy any image with a security vulnerability, whether it's a rollback or it's a roll forward. If I still need to deploy or roll back to a previous image, as I said, we can go to the policy and give an exception for this particular application, for this particular environment, because this is a critical bug and we need to deploy, right? But the idea is to say that how do you surface information for the developer at the right place? Is the developer going to look at an image at one place and the potential vulnerabilities at another place and then try to sort of put them together and say, oh, is this image correct or is this image not correct, right? The more you put those kind of cognitive overload for the developer, the less they are going to be aligned with the SecOps posturing that the company has, right? So this is, for example, something that you are talking about, like how do I show it in the system, right? The other place that you may show it may again be related to the deployment. So this is the window that I'm showing you right now is an application detail window, right? So this is saying that, okay, this image is deployed on, so this image demo application is deployed on production environment. And this is application status, and these are different objects, Kubernetes objects, which are deployed in this application for this particular environment, right? If you see over here, it is showing that there are a set of vulnerabilities which exist in the system. Now, there are vulnerabilities related to images, there are vulnerabilities related to licenses. The licenses of those are compatible, not compatible, right? Similarly, code scanning related vulnerabilities. You may be using some third-party softwares. What are vulnerabilities in that? What are the license issues with that, right? So all of these informations are again visible to the developer in the application. So the developer looking at it can quickly figure out like where the issue is, which application it is related to, which environment it is related to. And therefore, it becomes much more easier for the developer to know what is the next action that the person has to take, or where he would see what are the challenges and what are the fixes, right? So this understanding the context of the user and showing user the information in a way where the user can take right action on that information is also one of the important things when we talk about shifting towards the left, so that we can have those vulnerability fixes faster, right? Now, you might be saying that these are the vulnerabilities in an already deployed application. So where is the shift left comes in, right? And this is where I was talking about saying that what is the right posture? Is it the shift left, or is it the shift right, or it's something different, right? So the right way to do it is, of course, to shift left, but also to keep things on the right. Why? Because vulnerabilities are not something which is static in nature. So I build an image today, I test it for vulnerabilities, and it may have 0 vulnerabilities. But even 5 hours later, suddenly you may find that 5 new vulnerabilities or high critical vulnerabilities have been discovered in that image, right? So it's not a point in time problem. It's a continuous time problem, right? It's a continuum. So even after you have deployed the application, there is a possibility that new vulnerability gets discovered in the system. So on the right side also, you will have to always keep on scanning the images which are already built and which are already deployed, because you would want to know about those vulnerabilities as soon as possible, right? Now, the key is to know about them as soon as possible. So how do you go about doing it? How do you know about the vulnerabilities? Or once you have figured out the vulnerabilities, how do you get to know? Now there are different things that you need to do, and Defton provides something which we called a resource watcher or a remediation system, right? So the way it can work is, for example, if you're using Privy or you're using uh, Aquasec or something else, right? So what happens is now all of these systems are the CRD first systems. That essentially means that when they scan the system, they create vulnerabilities as a vulnerability list, a report as a part of the CRD, right? So what you can do in the system is you can actually say what are the namespaces that I want to watch. Let's say I want to watch all namespaces, and then I may say what are the resources that I want to watch. These are the resources, all resources which are available in the system. And in cases, if let's say you're using Privy or you're using uh, Ecosec or something else, they maybe have created the CRD over here, which provides you the vulnerability list, and then you can write a CEL expression on it saying that, okay, if you can go through the list and say that if any of the vulnerability is critical, so then take action on it, which may include alerting someone, sending out an alert, which may include even the Copactic plugin that I showed you, using that to patch the image and deploying it to a system, right? So all of those kind of things are possible uh, based on the vulnerability that has been detected in the system, right? So this is about completing the loop, right? So we from the right we shifted to left, but then we said that you still need things on the right, and you need to complete the loop from the right to the left so that people can again take action on any of the issues that might be happening in the system which are related to the DevSecOps. This may even include, for example, cordoning of the nodes, which has those kind of which has those images which are vulnerabilities, so that no new image gets deployed on that node, right? So at least the nodes get isolated for that particular image, right? So for example, these are some of the things that can be done from the DevSecOps perspective, where when you are talking about moving from right to left, but then also ensuring that the right still exists so that the loop gets completed, right? So these are like some of the things that I talked about today, and also like Deftron as a product sort of brings those things into the system to ensure that SecOps team, DevOps team, and the development team can sort of collaborate together in a much better way, and to ensure that the vulnerabilities are discovered as soon as possible and are acted upon. And even in case where vulnerabilities are discovered later on, how do you sort of ensure that your loop gets completed and you are still able to fix those things and are not, or at least able to reduce the impact of the vulnerabilities which exist in your environment today. So with that, I'll pause over here. If anyone has any questions or anything, Jim, if we had any questions, we can answer that.
Yep. So now would be a great time for anyone who does have questions to go ahead and type those in, and we will get those questions answered. While we're doing that, I'll ask a question, Prashant. How frequently should people be doing scanning through these pipelines? Is it every time the pipeline gets executed? Is it some other frequency?
Right. So every time the pipeline gets executed, you should be doing the scanning. And when I say pipeline, I keep CI and CD separate, right? So typically what happens is people believe that your scanning should happen only during the build phase. But I believe that whenever you are deciding to deploy that image on a particular environment, and that environment is a sort of a policy driven environment, you would want to sort of rescan the image. And even after the image has been deployed, you still need to rescan the image periodically for all images which are deployed, because if you don't do that, you may be blindsided by the new vulnerability which has been discovered in an image which was earlier safe and secure but now is vulnerable.
All right.
Right.
So up on the screen right now is a free content offer. So as I mentioned earlier, there is this content that is complementary to what we've been talking about here. You don't have to fill out any forms or anything. So if you scan this QR code, you will go straight to that content. And if you want to, you can bookmark that and come back and review that at your leisure. We did include the table of contents here so that you could see, exactly what topics are covered in that content. I don't believe we have any other questions right now. So if you would like to learn more about Devtron's DevSecOps offering, please feel free to visit us at devtron.ai. We would love to talk with you. You can also, if you want to follow us on LinkedIn, you'll get notified when we do more of these presentations. So thank you all for attending. Prashant, thank you so much for all of the knowledge. Appreciate it and look forward to doing more of these in the future. Thanks all. Bye-bye.
Thank you.